Hello and welcome to your week 12 quiz help video. This week I'm going to try to talk about these questions and not specifically tell you the answers. I'm going to do a lot of talking about which answers are not correct and why. So here it goes. Alright. Number one, you guys should know this. You can Google that one if you don't know it. Number two, I'm seeing a ring here. That means we have to put a cyclo in front of the name. And there's there's only one of those. I guess I told you the answer there. Oh well. And also there's 6 carbons. These 6 places where lines meet. The prefix for 6 carbons is hex. So you'd also expect a hex in the name. And this, a carbon single bonded to an O, single bonded to an H, that's that's a functional group, an alcohol molecule. So, alcohols have OL at the end of their name. So, we put that all together, we get cyclo, hex, and all. So that's how that works. If this was a aldehyde group instead of an alcohol group, you can call aldehydes al. So you would have an al ending instead of an all ending if this was an aldehyde instead of an alcohol. Alright. This one you guys can figure that out. Okay, let's see. Which of these are true? Are carboxylic acids strong acids? We know that acetic acid in vinegar is not a strong acid, and it is a carboxylic acid. And we eat carboxylic acids all the time. They're in preservatives, etc. So they're not strong. Do they completely ionize when dissolved in water? That's the definition of what a strong acid does. So that doesn't work either, because they're not strong. And obviously they're not bases. So we can eliminate several of those options. Okay, and that brings us to a big theme of the whole organic chemistry section in this course, which is the series of reactions that alcohols undergo, their oxidation reactions. And there's a lot of slides about this, and there's a whole video of me explaining some specific reactions of alcohols undergoing oxidation. So, I'll just leave it at that. All right, number 6. All right, so the idea here is that the more polar molecules that have more dipole-dipole attractions between the molecules are going to be harder to melt and boil. So more polarity means higher boiling point. We're looking for the one here that would have the least polarity and therefore the lowest boiling point. And I have written out these molecules for you. Here's your propanoic acid. This is the carboxylic acid functional group that's in propanoic acid. Is this polar? Yes, it's asymmetrical. The right side is definitely a lot different than the left side. Is it very polar? Yes. Why do we know that? Because there's the potential for hydrogen bonding to happen between these molecules. How do we know when hydrogen bonding can happen? When we see a hydrogen that's bonded to either a nitrogen, a fluorine, or an oxygen. So hydrogen bonded to oxygen in a molecule will tell us that it's probably significantly polar. So this one we can eliminate because not only is it polar, it's very polar because it has hydrogen bonding. B, let's see about B here. This one does not have hydrogen bonding. but it is slightly polar because the top, the way I drew it here, the top is different than the bottom side. So it is slightly polar. This might be a good prospect. We'll come back to it maybe. Here's C. This is an alkane. One thing to know about alkanes is they're not polar. So I can't imagine we'd find a less polar molecule than this in our choices. This is an aldehyde group. It is polar. The right side is different than the left. There is asymmetry. And here in E, this is our alcohol. And we have a hydrogen bonded to an oxygen. So there is not only polarity, but hydrogen bonding. So it is very polar. And so it looks like C is going to be the least polar one here. Okay, what is true about molecules with carboxylic acid functional groups? The acid will melt your intestines. We eat carboxylic acids all the time. They're in fruit. They naturally occur. We add them to foods. They're not going to melt your intestines. We just saw in choice A in the last question that they do form hydrogen bonds. Let's see this. I don't think we can eliminate number C here. This doesn't quite make sense because hydrogen bonds occur when a molecule is polar. And okay. What is the heteroatom in carboxylic acid? It's oxygen. What about an alcohol? Also oxygen. So it would be weird then if they could react and form a functional group that has a nitrogen in it. The nitrogen would just come out of nowhere. That would be weird. You'd have to have some kind of nuclear reaction going on. And a little hint, we don't. Outside of talking about the nuclear chemistry chapter, we're not going to have nuclear reactions happening. All right, okay, so this is the easy true false section. I'm going to fly through here. For this one, read up on that very important topic that I'm stressing in this course, which is the oxidation of alcohols. Same with this one. Let's see what we can eliminate here. Amide, that is a functional group with nitrogen, not sulfur. Do you guys remember what a micelle is? This is a big group of soap molecules when they surround oil or dirt. And acetone has a ketone functional group, and a ketone is another one of the functional groups that has an oxygen in it. Can we see that? Yeah, it's an oxygen double bonded to a carbon in the middle of a chain. Okay. The alcohol that can cause blindness. Okay, is it ethanamine? No, an amine is an amine with a nitrogen. It's not an alcohol, so that can be instantly eliminated because it's not an alcohol at all. Ethanol, that's the stuff you do want to drink. That's in your whiskey and beer, wine, etc. Methane, that's an alkane, not an alcohol. And methanol is a smaller alcohol than ethanol. It's what you want to pour off. It's what you want to get rid of. It's the first stuff that you distill when you make moonshine. It's what you want to pour off and get rid of. And this stuff is the same as glycerol, which is a byproduct of soap making, and they leave it in the soap. Okay, so just naming this guy. Here's something to know. It's, we're going to start numbering the main chain carbons from the right. So this is 1, this is 2, this is 3. our methyl substituent is on the third carbon, so it would be a 3-methyl. And, well, that's obviously carbon 2, and that's where your functional group is. And I'll leave it at that. Okay, let's talk about what functional group this is not. You might look at this and say, oh, there's a carbon double bonded with an oxygen in the middle of a chain, but it's actually not the middle of a chain. It's at the end of a carbon chain. The carbon chain stops here. And if this carbon's bonded to not one but 2 oxygens, it's either a carboxylic acid or an ester. Or something more complicated that we won't cover in this course. But this looks like a carboxylic acid here. And what would the prefix be? Well, there's 3 carbons, and it goes meth for 1, eth for 2, prop for 3. Hint for the carboxylic acid found in butter, it's like it sounds. It's like you would think it would sound. Hydration of an alkene. Okay, I think we saw something very similar to this in the last chapter. If you add, water is H2O, you add an O and 1 H to a carbon, and just the H from the water to another carbon, you end up with a carbon bonded to an O bonded to an H, and with all single bonds. And I'm gonna stop myself from saying any more unless you figure out what that might look like. Actually, I can't help myself. I'm gonna draw it. It would look something like this. A carbon single bonded to an oxygen, single bonded to a hydrogen. What functional group is this? What family of molecules would this be in? You figure it out. And that brings us to our last question. Again, ethanol is okay to drink. That's the stuff in wine and beer. 2-propanol. The second carbon is the middle carbon in this 3-carbon alcohol. And there's a common name for this. When you have 3 carbons in a row, it's called prop. And when something is attached to the middle carbon, it's also called not just 2-prop, but isoprop. So an alcohol, the OL tells us it's an alcohol. An alcohol with the OH group on the middle carbon is also called isopropyl alcohol, which is, we know what that is. It's not an antifreeze. We just talked about this stuff being in soap. This is a good candidate. And then this is, what did we say about aldehydes? What can you call aldehydes? Oh, honey, when you call me, you can call me Al. Oh, da-da-da-da-da-da. So this would be an aldehyde, not an alcohol. All right. Good luck with your quiz. Let me know if you have questions.